Hello, welcome back to More Fun Fixing It. I'm here today with a couple of 48K rubber key Spectrums. These were two from a recent triage episode where I diagnosed, I think, 6 of them. And these two were dead enough to make some content about. The others, not so much. This one says dead, and I decided that it didn't have any voltage because maybe the 7805 was dead. Having edited that triage episode, I think that possibly TR4 might also be dead, but that could just be a symptom of the voltage regulator going bad. So I'm going to look at that one first, and we'll just do a quick run through of the steps I took to get to that conclusion and make sure, just for our sanity's sake, that the conclusion that I got to was the correct one. I don't think this one is going to be very complicated to do, so I brought this one in as well. And this one says ULA good, which we tested, and it is good in another machine, but bad. Oh, CPU, question mark. So the CPU might be bad, and it's also got a bad power jack, so we need to change that as well. But let's do this one first. Let's run through the procedure that I use to check everything before I switch anything on. I've already switched this on, and I'm confident that I can switch it on again and not have any problems. But this is the route I take. So I measure resistance between the input side of the voltage regulator and ground, and that isn't shorted, so that's fine. And the output side is 1.2K. You know, as long as it's not shorted, that's fine. I also do the voltage rails on the lower RAM, so I think that's -5. Oh, I can't remember which one is which. But as long as none of these are shorted, that's fine. It's -5, 12, and I know that this side is +5. And none of them are shorted. So we should be good to go. Something unusual on this one, actually, is this the caps down here, these 100 microfarad caps, are usually axial, and these are radial caps. So the leads are coming out of this end, and one of them is going over the top and going back into this end. That is quite close to shorting out on the case of that one. So is that one. Not ideal. I mean, it's certainly, you know, if you can't get hold of axial caps, then it's an option. And I've done it before myself. Not one I'm a big fan of, but not the worst thing. Another thing to note is that this one's had its DC-DC mod done. This looks like it was probably done in the factory, and it's got quite a large cap on top of there. Doesn't need to be that big. And that resistor has been changed there as well. On the other side, there's no rework on this at all that I can see. It all looks factory to me. Oh, another thing is the LM1889N chip, the video encoder chip over here, has been replaced. That does look like that has been worked, but probably back when this was a current machine, so back in the 80s sometime, somebody worked on this. They also put a big scratch in the solder mask there and across that trace, but I don't think it's broken. Yeah, I think actually, I'm going to take it back. I don't think that this cap here is factory. I think that was added later. That looks around that area like it has been reworked at the same time as this was done. This video is sponsored by PCBWay. Now, you'll know PCBWay for their PCB manufacturing, assembly, and even 3D printing, but one of my favourite features on their site is the shared projects section. It's like a community library where makers and engineers post their PCB designs. You can browse through thousands of projects, get inspiration for your own builds, or even order the boards directly. If you've designed something yourself, you can upload it and share it with the world, and even earn a little commission when other people order your design. It's a brilliant way to give back to the community, discover clever design ideas, and maybe even make your own project more widely used. So next time you're on PCBWay, check out the shared project section. You'll be amazed what people are building. So what do we do first? Oh yeah, so we've checked the resistance on the voltage rails. I just checked the resistance across the coil. So it should be open across here. And there is some resistance there, but there often is. It's quite a difficult thing to check, and sometimes you'll need to change the polarity of your leads before you'll get a true reading. But this one isn't doing that, so maybe it could be something to do with the coil. That should be shorted that way, and that should be shorted that way. That's fine, but these should be, or they should go open after a little bit of resistance there. Anyway, I'm less worried about that, because even if you do find something there, it's often something to do with TR4 and TR5, which are the voltage regulators to do with changing the to do with the DC-DC conversion from 9 volts to 5 volts, minus 5 volts and 12 volts. So if I go into diode mode on my multimeter over here, and we check. Now this is where I slipped up in the triage, because with the black lead in the middle and the red lead on the outside, you should get nothing and nothing. Now with the red lead in the middle and the black lead on the top, I should get like 0.7, and I'm getting 1 volt there, and just under 0.6. So I think that is a bad transistor. Just check TR5 over here, same thing, black lead in the middle, 0.7, 0.7, that's normal, and you should get nothing one way and 1 point something the other way. That's normal, so that one is okay. I think this one's bad. So I'm just going to pop that out and give it a test. Before I do that, I just want to show you what's happening on here, because I haven't actually shown the actual symptoms yet. So if I put power into this, and if you look here, it should show you 12 volts, 9 volts, 5 volts, and minus 5 volts. And we're only getting 9 volts, which means that it's not getting any further than the voltage regulator. That's why I thought that the voltage regulator was blown. But I also think, it could have blown because of something going on with this transistor at TR4. But let's take that out and just check it out of circuit, because the reading on that transistor could be because the voltage regulator is blown. They are both in very close proximity in the same circuit. I'm going to try and take this one out manually. That's pretty good. Get most of the solder out, and then heat a leg and give it a wiggle so it's moving. Keep moving it whilst you take the soldering iron away, and all 3 legs come loose. And then you've still got to be careful on the top in case it's still attached, but yep, that's just moved. Comes straight off the board. Got my snazzy new FNURSY. Oh, I say my snazzy new FNURSY component tester, but it's missing a vital part. Oh, that's just not the best build quality FNURSY. Ah, that is blown. Okay, so it's saying it's a diode between pins 1 and 2 and nothing between the others. Let's just double check that. I'm still in diode mode. So yeah, I'm still getting 0.5 between one leg, but nothing between that one and that one. So yeah, it's blown on one side. However, I do believe that the voltage regulator is blown, and I'm going to take it out anyway and test it outside of the board. I don't think that this can test voltage regulators, so I'm just going to have to hook it up to my bench power supply and test it manually. Marvellous. Right, so that's the output side, and that's ground, that's the input side, and that's the output side. So I'm going to connect black lead to this, red lead to this, and then we're going to measure this one. But I need to do it in a safe manner. So let's move that one up there and stick this in some blue tack to keep it still. Some crocodile clips, banana plugs to attach to my bench power supply. Right, so black lead on there, red lead on there. Make sure nothing's connecting. I'm just going to hit this with an amp of 9 volts on my bench power supply and see what happens. Right, nothing, so that's good. Let's just connect up a multimeter. See what it does. Yeah, it's just gone. Oh no, that's not. 3.64 volts. That might not be enough. So it should have 9 volts going in, and it's only got 3.6 coming out. So it's actually, oh, I didn't spot that. Does that get hot? No. There is, I don't know if you can see it on there, but there's a big old crack going down there. Yeah, you can see it just there. Yeah, that's broken. Here is a brand new replacement. This is a 7005 SCV. No, 7005 CV. I think these are like 2 amps. They're higher rated than the originals, and this should never blow up in a Spectrum. Oh, you need to bend the legs so that they'll fit, and the heatsink will be able to go on. So let's just put it in place. Nice big hole on this one. I don't remember it being that big. And yeah, they basically need to go straight down. Yeah, it feels like it should be, it should bend at this point here where the legs go a little bit thinner, but it's not. It's actually about halfway along there. So I'm just going to give them an initial bend like that. I need to clear these holes out a little bit more. They're reluctant to take the new voltage regulator. I'm going to use some braid actually. On both sides. There we go. That's better. Right, before soldering that in place, let's put the heatsink back where it was. And screw this in place so that you don't, if you solder it in place, then you're going to struggle to get this in. It shouldn't really need any thermal compound. Right, and now just solder that in place. Could have cut the legs off first. That probably would have been sensible, but I've got nice sharp snips. And just to be sure, I'm going to reflow each one. In case I've fractured any of that solder, that fresh solder. I doubt it, but it might stop people complaining at me. Now, TR4, which is the only transistor in here which really needs a good quality replacement. Pretty much everything else in here, including TR5, can be replaced with your common or garden transistors that you'll find in most kits, as long as it's an NPN and not too far out of spec, or a PNP if it, whatever the case is on each one, that it matches, then it should be fine. But this one takes a huge amount of current and will burn out very quickly, even if it is the right type of transistor, and the machine is put under load, which on this part of the circuit is all the time. There we go, lovely job. Right, put it back in its case so that it's safe from all of the bits of metal on my workbench. It doesn't feel like it's sitting in the bottom of the case properly. Anyway, let's connect it up to video capture, just in case it does show an image. I'm using my Henry Instant composite mod here, designed by Henry. Right, and put the power supply back down to 800 milliamps and 9 volts. And I'm going to attach the Steam Card Pro so that I can see the voltages. If they're there, then away we go. They're there, and it's running. And it's got a picture. And it's got a broken RAM. Fantastic. Let's see what the Retroleum Diagnostics says. Oh, it's saying the lower RAM's okay. Oh, here we go. Right, IC21. This is great because they're all in sockets. It really doesn't like it when I do that. I'm just going to give this edge connector a clean because it's obviously not making a good contact, because the as I lifted it up, it freaked out. So let's just give that a quick polish with my Future Was 8-bit edge connector cleaning tool. I'm happy to be sponsored by the Future Was 8-bit. It's not a real sponsorship, so... oh yeah, this edge connector is a bit crusty on the back. They don't often get crusty on the back, but this one looks like it's been well used. Might have to get a bit more aggressive with this one. That is probably good enough. Let's give it every chance of working. I often just skip through these in the edit, so you won't always see the whole diagnostics. Sometimes you'll see a sped up version, and sometimes you'll see a cut version, but I always let it run to the end. Well, if I need to, I'll let it run to the end. That's not good. It's a different IC this time. Let's go back to the other one. I'm wondering if it's a logic chip. Okay, that's passed the lower RAM test on. What's going on there? Just check the voltages, and the voltages are okay, are all good. Right, so I think the sensible thing to do here is to actually remove all of this lower RAM and test it without it as a 16K machine. Perfectly valid way to do this, because the memory is probably not the problem, and removing it might make it a working machine. And if I can test this memory in another machine or in a tester and it's okay, then that really narrows things down for me. Horrible sockets. These look like factory sockets. They're single wipe. So this could be a part of the problem. Here we go. I expect this will still throw a fault. Okay, it didn't throw a fault. Let's try the other diagnostics. Okay, this is now a fully working machine. So now I'm thinking it's one of these. So in Spectrum, ZX Spectrums, the lower memory is, I mean, the first machines were only 16K, and they only came with these two 74 LS157s multiplexers to control the lower RAM addressing. And when they got increased to 48K, by adding these 8 DRAMs here, then these 4 chips were introduced as well, and these control the multiplexing for the upper RAM, the upper memory. So it's probably not ULA, it's probably not CPU or ROM. It could be something mechanical. It could be a bad trace or something, or a bad socket. Possible. I don't think it is. I think that the problem lies with one of these multiplexers. But which one? What happens if we just put one back in? What? That's the same fault. Does that change if I move it? Well, I think what I'll do first is just take all of this memory and just run it through a chip tester, just to rule out any properly dead chips. And for this one, I'm going to use my Pico DRAM tester this time because it's quicker than the other ones. Okay, so we're over here, 4164s. What are these? These are, it doesn't give a speed rating. Oh, I think they're 20s, 200 nanoseconds. Failed. Huh. Ah, that is because I've forgotten this. I don't think this, well, I need to update the firmware on this. I think that this version can't test these half-bad chips. And that is exactly what these are. When Sinclair cheaped out buying their stock for the new chips, they bought some half-bad chips just so they could get them cheaper and only use 32K. This is 64K of memory. It was that one that I tried first. Oh, no, okay. That is just bad. All right, this... Oh, that's bad as well, but in a different way. So it should show 2 green and 2 red if it is a half-bad chip. This is going to be all green, okay. So that one can go back in. Actually, that was from there. That one needs to go there, just if I want to keep them all in the original places. Another bad one. Wow. Okay, so maybe that's why this was really messed up. So this one and this one and this one so far have been bad. Another bad one. Yep, same thing. And another bad one. Oh, wow. 5. 5 out of the 8 are bad. Okay. Let's get some replacements. Normally don't worry too much about, you know, the odd chip here or there being bad, but this is a lot. Right, so I'm going to have to go through, straighten all of the legs out on these chips, test them all, and then let's see what happens. All of this for an issue 2. All right, last one. What will that do? Okay, so 5 really bad chips. 5 bad chips, voltage regulator and TR... Shush you. 5 bad chips, a voltage regulator and TR4 needed changing on this one. And the ULA looks okay actually on this one. That's not bad. I will do a composite mod now, just to finish this off. Marvellous. Perfect, that is. Let's connect it up again and see what happens. This time using a normal composite lead. There we go. Not bad. I don't remember what the case... Oh, the keyboard on this one is probably gone. But we'll give it a go. You never know. Sometimes these can just be okay, even looking as terrible as this one does. No. Not a sausage. Nothing. So that'll need a new membrane. It's not a bad one. This is in decent condition. The faceplate is just a bit grubby. But the actual... A few spots of paint on it. But the plastic's look in good condition. So that will... Oh, and it's a nice easy one to do, to change, because it's got the brass tabs inside. So this is not stuck, or it shouldn't be stuck down. This is how they used to do them. And then they changed to gluing them down with double-sided tape. Let's see if it plays again. I'm using a new capture device now, so I've got no lag to blame. It's still a bit dark and small. Ow. There we go. I win. Right, message time for Paul. So it was the 7805, but it was a few other things as well. 7805 plus TR4 plus 5 upper RAM. Oh, terrible writing. Plus bad membrane. Done. Right, so this one I'm going to actually leave to the next episode, because the other one was a bit more involved than I thought it was going to be, and I think this will just make a nice episode all by itself. And yeah, you'll have to wait for the next one. Right, thanks for watching. See you in the next one. God, I think I got away with that.